Hi everyone, welcome to the Ben and Chris show. I'm Chris, this is Ben, and this is the last episode of the Ben and Chris show where we've been teaching you Python over, it feels like quite a long time now, but it's only 8 episodes. So hopefully you've learned some stuff along the way. Today we thought we've been talking about data analysis. Last week we finally got around to some data analysis. And today we're going to talk about how to visualize some of that data using MATLAB. Using Python, using the Matplotlib library, which is, for some people will be reminiscent of their favorite data visualization software. Ben, should we share screen and get started?
Yeah, sure. This is all about data visualization. So I think, one part of analysis is crunching the numbers, and we talked about that last time. But, a big part of this is visualization. And yes, as Chris said, this is very similar. If you've done MATLAB before, then this library, what we're going to use, Matplotlib, I'll write that down for you, like this, Matplotlib. It is a very good library for data visualization in Python. I think it's one of the, I wouldn't say a standard library in Python, but it's probably the most popular library out there for any kind of data visualization. There are other ones like Plotly and all other kinds of libraries, but this is usually the one that people go to. So that's what we're going to be using today. The other cool thing about Replit, which I didn't mention before, is it actually has it has a GUI. So if you're wondering why this thing is split into two, this thing in the top right and this thing in the bottom left, it's because Replit allows us to look at our little charts that we make in here. So we're going to have... Oh, sorry. Carry on.
No. I was about to say something. I was just saying it's worth remembering that you're talking about using the library. Now, again, we've gone through this all quite quickly, but it's useful to remember that we have already used libraries before. We've used them in other episodes, like the stats package from last time. So although using a library might sound a little bit scary, or you think there's something additional you need to install, again, it's all built into the way Replit works.
Yeah, so last time, for example, we used import statistics, and you probably remember we did statistics.mean, right? Say we have a list and call this, I don't know, data, and set this to 1, 2, 3 or something. So list, and then we put in data here. If we print this out, it will show the mean of this, right? So if I run this, it should show us, well, in this case, 2, right? So what this means, whenever you see import, it usually means go off, find somebody else's code, in this case called statistics, and use that. So we're using the mean function from the package statistics. And basically, we're going to do the same thing here. We're going to use Matplotlib. So on that note, the first thing to do to get started with Matplotlib is to actually import it. So if I get rid of all this, the first thing, I've got the code from last time down here, so we're going to jump into that in a bit. But let's have a look at how you import Matplotlib. So usually what you write is import, and then you put Matplotlib. Now, Matplotlib has a bunch of different stuff in it. It has things for plotting stuff, but it also has other things inside it. What we're concerned with is just plotting. So we're just concerned with making graphs and stuff. So let's do .pyplot, okay, as plt. Now, what this means is import this package, right? And whenever, do you remember we did import statistics, and then we did statistics.mean? Well, another thing we can do is we can import this as a name. So if I call it as stats, I can use stats.mean. So I can call this whatever I want. I can call it S. So basically, it's saying replace S with statistics. That's what's happening here. So instead of typing out all of this, you can just type in plt, or whatever we want. We could call it matplot or something. But I'm just going to use plt. So if you see plt, it just means matplotlib. That's all it means. So that's the first step you need to do, is import matplotlib. Now I'll go through some of the basic functions of Matplotlib. So before we actually start using real data, I'll show you some example data.
Speaking of example data, we have had a fun. So this won't apply too much for people if you're just watching the show now. We do also have a Teams channel where we're talking about stuff, and there has been a request for the data that we used last week. So what we will do, again, in the link just below down here now, all the Ben and Chris episodes are available on the University of Lincoln website, lincoln.ac.uk/home/socks, the School of Computer Science, /the Ben and Chris Show. And we will be adding that data set. Again, it's just a random set of data. We'll be adding that to that page so you can do the experiments yourself. And there's cool worksheets and interactive stuff on there as well. It's a whole party of Python.
I think that's another thing is if you've been following along to this series and you think, oh right, I know some Python, but I'd like to test it out. Those worksheets are a really good idea. So just there's some exercise in there that are based around what we've been talking about and stuff. But yeah, this data here we'll pass it over. So yeah, the first thing to do with Matplotlib is to plot, right? So if I do Plt dot and I do plot, right? Now, what this is going to do is it's going to plot a list of things that we want to give it. So what you can do is you can give it, what I'll do is I'll type it out. So if I have a bunch of X coordinates like this and a bunch of Y coordinates like, let's say 5, -1, 5, 3, and 5.8. Well, actually, let's switch it up. Let's put 9 and maybe something big like 35. Now, what you can do is you can say plot X and Y. Now, you can just put in Y and it will kind of put this already for us. But what we're going to do is we're going to say these are the X's. All of these are the X's. So these are the X coordinates. So it's going to plot a point at 1, 5. So then it's going to plot a number. It's going to plot another thing at 2, -1. 3, and you can see where this is going, right? 3, 35. So it's gonna plot using these X coordinates and these Y coordinates. Now the next thing to do is Plt Dot Show. So this is simple. If you've ever done MATLAB, this is very similar. Where you've got figure, hold on, show, and all that kind of stuff. This is pretty much the same. That's why it's called Matplotlib, is because it has a MATLAB style interface for plotting things. So if I run this, let's see what we get. You might see this thing. Don't worry about this, and it shows us this little graph here. So as you can see, we have, well, we've got the first point we've got at 1, 5. So we can look at this, right? We've got 1 on the X here, and 5, which is here, 5. So we've got 1, 5, and that's it there. So that's the first point. Then we've got 2, -1. And I won't really explain the rest because it's probably pretty obvious. So we've just made a little chart using 2 lists, right? Just 2 lists of numbers, and that's really good. If we wanted to omit these X's, we can put in just Y, and it will automatically put 1, 2, 3, 4, 5 in there for us on the X-axis. So as you can see, but what I'm going to do is I'm going to use X. So we're going to actually put these stuff in there. So if I change this 35 to something huge like 250, and I run this, see that the plot will look very different, or maybe not actually, but you can see that the scale of this thing has changed dramatically. But it's a really nice little library, right? We can use this to plot any kind of data we have, and we're going to connect it up into some real data later. And Matplotlib has so many different plot types. So we have here, we're just plotting 2D coordinates using some kind of line graph, right? But we can also use things like bar graphs, right? So if I have, I can't think of a really good example of some bar graph data, but let's do
ages,
yeah.
Red cars versus blue cars.
Yeah, okay, that's a really good thing. So what we can do is we can say, let's call it names, right? So these are the names along the bottom. So we've got red cars, blue cars, and we've got maybe yellow cars or something. Right, so we've got some data, and we've got counts, right? So we got, in this case, the amount of red cars are, I don't know, you don't
50.
see much. 50, yeah. You probably see more blue cars than red cars, so I'm going to put, I don't know, 63, and you don't see much yellow cars, so I'm going to put
1042. It's been a long day. 7.
7. Yeah. So what we're saying here is we've got 2 lists, right? We've got names, and the first element of names is red cars. There are 50 red cars because we have counts. So what we're saying is this index corresponds to red cars, and then blue cars, and so forth.
Just to explain that a slightly different way. So again, remember we've talked about indexes before in this show, where the first index is 0, the second index is 1, so on and so forth. These two things are aligned by their position in the list that they're in. So the first item, index 0 for the names list, is red cars, and that will always correspond to the first index of the corresponding list, which is counts, which is 50. Just in case that is a bit confusing.
Yeah. So Chris is exactly right. So this here is the 0th element. I know it's quite hard to wrap your head around the 0th element, but it's the first thing in this list, right? It's index 0. This is index 0. So what we're saying is there are 50 red cars. There are 63 blue cars. So this is index 1. This is also index 1. So we're kind of bringing these together by their index. So you could space it out like this to make it a bit more obvious, I guess. But that's what's happening here. So if I bring all this stuff back, all the way back here to here, and I do plot dot bar, I think it is, and we can put in names along the X, and we can put in counts along the Y. So this is saying make a bar chart with names along the X, so down the bottom, and counts as the Y value. So if I run this, we should get a bar chart out of this. Here we go. Yeah, so now we've got a nice little chart that says, there's 50 red cars, 60 something. What is that? 63 blue cars, and 7 yellow cars. And this is pretty cool. We can do all kinds of stuff with this. One
thing that's worth saying is this, much like some other plotting software as well, is actually designed around a whole bunch of best practice in data visualization. So you can see that there's not huge amounts of chart junk. There's not loads of lines going across. Genuinely, one of the most frustrating things when people design charts in Excel is the amount of extraneous information that's on there. The things like bar charts, they don't need to be 3D. In fact, making them 3D obfuscates and makes the information harder to read. So the nice thing about Matplotlib is it started with the published, the kind of accepted from the data visualization community best practices in visualization. Very little chart junk. It is missing axes though.
Yes.
Labels.
So this is the next thing, right? We can start adding stuff to this. So if we wanted to customize this chart and we wanted to, as Chris mentions, we've got we don't have any axes here, right? But so for example, this y-axis, what does this represent? Sure, yeah, we've got red cars. We've got 50.
But that could mean, how cool is a red car? Well, it's 50 cool.
50
Clearly not as cool as a blue car.
Yeah, and yeah. So we need.
How many people can you fit in a red car? At least 50.
At least 50. Yeah. So this could mean anything, right? This unit could be in anything. So if we want to clarify that, one way of doing that is to provide some kind of axis. And how do you do that? Well, if I remember right, I think it's X label. So plot.x label, and then you just put in the label here. So you want to do this before you show the chart. So that's what show does. You build the chart and then you show it.
You can almost think of that as, if you're writing a Word document, you have to write the document before you press the print button. If you press the print button and then write the document, you're just going to get a blank piece of paper. A lot of kind of graphic software, they have, you actually, right, software is relatively stupid, right? It only knows what you tell it. It only does what you ask it to do. So you need to tell, if we're kind of laying out where we want our labels, what data we want in our chart, we then need to say, right, we've done all that. You can now show the information. So that's the last command. It's kind of like I say, it's like pressing print at the end of your document.
Yeah. and print in this case is the process of actually showing it here on the right. So if you can imagine, using that analogy, if it's almost like saying press print, and your document prints out, and then you say, oh, actually now I want to type things into it. You've already printed it, so you're not going to see it, right?
There is no digital equivalent of being able to draw on it with a Sharpie afterwards.
Yeah, exactly. So what we do is we use X label is going to be down the bottom, so I should be using Y label instead. That's my bad. So if I put count or something here, so if I put count and I press run, it should compile. So one thing you'll notice about Replay as well is it takes a little bit longer when you press run to actually show this chart, because it has to actually render it out. So as you can see here on the left, along the y-axis, we have count, right? So we have we can change that to whatever we want. We can put number of cars, and that's probably a better label, but I'm just going to leave it as count. You can also do X label. So if I was to put something like
color of car,
color of car, yes, color of car, and then we could take out the word cars from these, and then if we press run, so what we've said is we're going to have color of cars down the bottom. Color of cars, we've got red, blue, green, and then on the left we've got count.
Green.
Sorry,
are you just blending together the blue and yellow cars?
Yeah, that's probably what I'm doing. Green. Yeah. So yellow. Sorry. The other thing you can do as well. So we've gone over X labels. This thing doesn't have a title. If we wanted to give it a title, we can use Plt Dot Title. Do something like, I don't know what to call it. Number of cars. Well, car color frequency or something. I don't know. Probably not a good title, and Chris probably told me off.
All right. Works.
Yeah.
Says what it does on the tin. Does what it says on the tin.
Yes. So here we got car color frequency. The other thing you can do as well is you can stylize this. So you could make this bold and stuff. And I suppose I'll quickly show you that. So what you can do, and we haven't really discussed this feature of Python, but what you can do is you can add in parameters that look like this. So you can say font size equals 14, and well, if I change that to 14, let's see what happens. So if I run that, it should be a little bit bigger. I hope I've got that one right. It does take a while to actually load these things, as you can see.
It's a lot quicker on the desktop version of Python.
Yeah. So on the desktop version of Python, you click run and your chart is there and then. But what this has to do is it has to take the code we've written, compile it, well, interpret it and stuff, and then spit out a chart, then render that back to us. So it takes a while. So don't worry too much about that. But as you can see, that the title is slightly bigger. So we can do things like this. We can do all kinds of stuff. You can also do other things, like if you wanted a grid for whatever reason, you can put in a grid. So here's an example of I've just took the title out, so I should have left that in. But if you wanted to display a grid for whatever reason, I mean, this looks awful, but
there's no reason to display a grid. That's very bad data visualization.
Yeah. So if
sorry, the graphic designer in me is just a little bit of him just died.
Yeah, it's it's an awful example of a grid on a bar chart of all things. But
one of my favorite YouTube series used to be this thing called Drunk Advice, where people got inebriated and then just did like this agony aunt type thing. I kind of feel like drunk data visualizations would be fantastic.
Yeah.
Let's see how we can visualize this.
So you can do all kinds of stuff with this. You can turn on the grid, and this is just the tip of the iceberg. I mean, we've covered just a few features here. Matplotlib has absolutely tons of things you can do with this chart. If you wanted to change the font, if you wanted to render an equation up here, if you wanted to change what these ticks up here, the interval and stuff, you can do that stuff with Matplotlib. There's tons of examples out there which show you how to.
This is worth saying. Matplotlib, something you might have noticed just by watching what Ben did. It works out the ticks, the intervals. So it's decided that an interval of 0 to 10 is most appropriate for this data. And it's done that by looking at the data that you've presented it. Now, if we did say size of ant, right, and we were working things in millimeters, you know, smaller measurements, you know, floating point measurements, it would have given us a different type of tick. It does a lot of that automatically. Now, again, data visualization is one of my research areas, and it's something I feel rather passionate about. The best bit of advice I can give you on, especially this type of chart, a bar chart, is don't muck around with the fonts, don't muck around with the sizes, put your labels in, but largely let Matplotlib do it the way it does it. And that, again, for anybody who's watching this, because I know we get some PhD students and so on watching this, it will produce charts that are suitable for publication. And you won't get a reviewer coming back to you and saying, oh, these are terrible charts.
Yeah.
Which happens, right? Because I review papers and I sometimes send papers back saying these are terrible charts.
Yeah. And definitely don't put a grid on a bar chart. That's horrendous. I was just doing it to show.
Wind me up, I think.
Yeah.
So I mean, grids can be really useful for eyeballing data, right? If this is your first kind of so for me, for data analysis, one of the first things I do is I'll often throw some I look at the world visually, right? So I'll often throw up some graphics and say, right, okay, yellow cars less than blue cars. That might be something I want to dig into in more depth, you know, do some statistical tests and so on. And sometimes actually having a grid, especially we were talking about if you're doing floating points, so, you know, we're doing lengths and we're doing very precise measurements. The grid can be quite helpful for that. Sometimes I'm trying to think of an excuse for dropping that much chart junk on. But as a general rule, and again, it's even in some publication guidelines not to include that kind of style. It makes it harder to print. It makes it harder to read. It's just bad. Don't do it.
Yeah. Another question you might have as well. So let's run this, right? So let's see what we've got at this. We've got our little chart. Now you might think, okay, that's brilliant and all, but how do I actually, if you wanted to do this in like a visualization and now put this into your paper, how do you get the file out? How do you get the image to put in your paper, or, you know, print off?
Do you get the file, Ben?
Yeah. How do you get the file? You know, you can print it off and, I don't know, show it to all your friends or something.
Stick it to your fridge.
Yeah, stick it to your fridge. Frequency.
Look, I made a bar chart, mummy.
Yeah. Yeah. Just
you know what? I'm living for the day that Tristan brings home his first bar chart.
Yeah. So you might think, you know, how do you do that? Well, the way you do it is it's quite easy. You just do PLT, and I think it's .savefig. So what you do is you do savefig, and you put in the file name here. So if I wanted to save this out as carcolors.png or SVG or PDF, whatever. So let's do PNG. If I run this, what's going to happen is it's going to plot this, and then it's going to save that. Oh, actually, hang on. That's my bad. I need to show it. I need to save it before it actually shows it. And I'll get into why that is in a second. So if we run this, as you can see here, it's popped up a new file called carcolors.png. So all this does, and if I click on this, you can see this is just an image of the chart we have here on the right. It's took the stuff here and it's rendered it here. So you can now, you know, as it says here, click to download. You can download this, put it in your paper or whatever.
And for anybody who writes their papers in LaTeX, if you don't use LaTeX, have a look at LaTeX. Oh, we should do a series on LaTeX, Ben.
Yeah, for sure.
But it's optimized, so it loads quickly. It's nice and fast. It's good.
Yeah. Now, you don't just have to use PNGs, and, you know, as we're on the topic of writing papers, and, you know, you want you want this thing to be scalable. So if somebody reads it, like zooms into your paper in their PDF viewer, or it's printed out into an actual journal, it needs to be high quality. So what you can do is you can either print as SVG or you can do PDF.
SVG being a vector format. And again, we could probably do a whole thing on vector formats, but vector formats are, for anybody who doesn't know, it's almost like using math or using numbers to describe an image. So it's something that scales because math scales.
Yeah, and you can use PDF for very similar things. It's supported quite well in LaTeX. You can just say, "Hey, here's my image. It's a PDF. Put it in, please," and then it will be scalable. So if I run this, what Matplotlib will do is it will look, oh right, a PDF. I need to save this as a PDF. So if I click here, you can see this is a PDF file with the graph in it. So you can save your figures out into a file, and now you can download this, right? As you can see here, you can print directly from here, and stick it to your fridge or whatever. So that's the way you save these figures. It's very useful. Most of the time, I do this. I have some kind of Python program that I read in data, and I just save a bunch of figures out using this. So I do, instead of manually generating each one of these and then clicking save and stuff, I can actually just run a script and it will just generate a bunch of things for me. So that's quite useful for this type of thing. So we've looked at saving figures, we've looked at showing figures, we've looked at customizing stuff. Next thing I probably want to do is talk about the other types of chart you can use. So I'm gonna get rid of this for a second, or maybe I should just comment this out. Let's have a look at scatter plots. So another type of chart you can use are scatter plots, and there's so many different types of charts in Matplotlib. We're not going to go over all of them, but we're going to look at some of the ones we're going to use in a bit when we get.
Could we use our data set, Ben?
Yes, we could. So before I got into that, I just want to show you what the scatter plot thing looks like. So say we have I don't know, we have data. Actually, to be fair, it's probably easier if we just get into the data. So let's do that. So what I'm going to do is I'm just going to delete this, and then I'm going to bring in our code from last time. I have added Matplotlib here. So if I undo this, you'll notice
it's like Blue Peter, isn't it? Here's one I made earlier.
Yeah. So I've got Matplotlib imported as PLT. The other one that I haven't talked about, which we're going to use in a bit, is called NumPy. And NumPy is one of the most popular.
Is it NumPy or is it NumPy?
I don't know. I've always called it NumPy. So what NumPy is, or NumPy, is it's one of the most popular libraries out there for any kind of scientific like any kind of scientific stuff with Python. So you can hold matrices and so forth.
NumPy, numbers in Python.
Yeah,
it's a whole math thing.
Yeah, it's a kind of math library thing, and it allows us to do some really cool stuff. So, and I'll get into that a bit more. But if you're wondering why I'm typing NP, that's what this is. It's NumPy. You just need this. So let's uncomment all this. So all the code that we did last time. Remember, we did things below this. We did we printed out the mean, we printed out the mode, we did all kinds of stuff. But we had this stuff here where all we're doing is we're running through the file, right? So we open up a file, okay? We open up a file, and then what we're doing is we are running through each line. We're getting rid of all the white space, then we're splitting them into columns, because as you remember, the data has commas between each column. And then we're parsing these. So we're saying the name is the first column, and the gender is the second column, and the age is the third, and so forth. And then we're saying if the gender is F, then add to female heights and female ages. If the gender is M, then do the same but for male. And then add to heights. So all we're doing really is we're going through that file line by line. we're extracting the data and putting it into some lists. So now, if at the bottom here we have print heights, and well, let's do male heights, I'd say, or male heights, and see what that gives us. Should have, yeah, you can see this is a very big list of all the heights that were in this big list of data here. So we talked about that last time. Now what I want to do is actually use this data in our chart. So do you remember we did things like plot, and we just passed in an X and a Y, right? So an interesting thing to do is to maybe plot the as a scatter plot. We can put in something like the male heights and the male ages, right? So we can have all the heights as the X coordinate, or maybe let's do ages on the X, and let's do heights on, as the Y. And if we run this, let's see what we get. So we're doing the same thing as before. Oh, and my bad. I should actually show this. So I always do this. When you do your chart, so whether it's a scatter, a plot, a histogram, whatever, just remember you have to show that thing. As Chris said before, right? You can kind of think of this as pressing print or in Word or something. So you've written your chart, but now you need to print it. So you actually need to show it. So let's run this. So it might take a while because we have to read from a very big file. But as we can see, we've got some really interesting things here. So we have along the bottom, we've got ages. So this is the age. So the X coordinate of each point is the age of that person. And along the top, we've got, along the Y-axis, we've got heights. So, it
almost looks as people get shorter as they get older. Slight bias towards.
Yeah. You can see there's some interesting stuff here, right? Now, what would also be very interesting is could we plot another thing on top? So if we did the same, but with female heights, right? So if I do the same, and I'll just clarify what's going to happen here. So what I've got here is I've got two scatter plots, right? And you might think that this is going to make two separate graphs like this. What's going to happen is it's going to plot both of these things on the same graph. So if I run this, you'll see that I don't get two figures. I get one figure with two things in it, which is, and now this is quite interesting data, we can clearly see that there's two separate groups here. So the orange, I think, is the male heights, or I think it's the male heights, and the other one is the female heights. So you can clearly see that there's a difference between these two groups, and this is quite interesting because this is actual data that we've pulled from a CSV, and we could put this in our paper and say, hey, look, there's clearly some kind of thing going on here. Can we change
the color of those plots, Ben?
You can, yes. So there are a couple of commands in what's it called to do this, Matplotlib to do this. I can't necessarily remember them off the top of my head. I think I'm just going to guess this. So you can pass in the first thing I'll do is I'll talk about this 2, right? What this means is the point size. So if I put in 2, what we can do is you can see that these ones are smaller. So if I put this back to, I don't know, 10 or something, and I'll explain where I'm going with this. So this is 10, and I run this. Yeah, we get points like this. The next parameter after this is the color. So we can put this as red, for example. So if we put in red, then we can see that these are red, and maybe we could do the same here. So we can do comma blue. So we know that the female heights are red and the male heights are blue. So if we run this,
if it's worth saying, if you keep adding scatter groups to that, it will give you colors for it.
Yeah.
Right. Now the problem with that is sometimes you can lose track of which color is what. So by manually just defining your own color scheme, it can be quite useful. It can actually just help you reference what it is, because I have actually seen this twice in a paper where the author has said, "Oh, and look at this group, which is red," and it's not. It's been the other way around. So sometimes it can be quite helpful.
Yeah, and the other thing to do as well is if you wanted to have like a little thing which says, blue equals, in this case, male, red equals female. There is a way to do that, and I can't remember it off the top of my head. I'll try it and let's see.
Can I just flag one thing that's really interesting with this? Actually, remember earlier we were talking about the ticks and how so the intervals of measurement down the side. Look how Matplotlib has automatically decided that in this case it is better to do by 0.2 measurements. Last time it was by 10 units. Now it's by 0.2 of a unit.
Yeah, and you can clearly see that this stuff on the left is meant to be height, and then this stuff around down the bottom is meant to be age. Just based on the ticks, because we've got 20 to 60. Well, you're probably not going to have somebody who's 60 foot tall. Chances that's age, and then this
still needs a label though.
Yeah, still needs a label. So we can do that. We can do plot dot x label as we did before. We can say age, and we can do plot dot y label, which is vertical. We can do height and then in feet or something, and we could even give this a title. So let's do something like male versus female height or something. I don't know, it's probably not the best name, but you get the idea.
And again, I'll just bring out something else, and again, this is just because I know we have a few PhD students watching these. When you're defining your colors, think of contrasts. You'll be amazed how many people don't seem to realize that often when papers actually go through the publication cycle, they get converted to grayscale, they get converted to black and white. And you can have, and again, this is useful for remembering for people who are colorblind as well. Contrast is a really useful measure between points, because red and blue of this kind of quality, when you convert that to gray, look like almost the same color. And actually in Matplotlib you can actually change, you can have dots, or you can have triangles as well, I think, and squares and stars and stuff. So looking at, just being mindful when you're designing your charts, it's one of my major bugbears that the chart will probably be converted to black and white, to grayscale, and your chart will need to work in that way. And also, just from an accessibility perspective, it will probably at some point be looked at somebody who is colorblind.
Yeah,
and don't do the female heights in pink, and that winds me up as well.
yeah. It's a good point there, and I think it's definitely something you need to consider with data visualization. I think there are some colorblind modes you can set in Matplotlib, and there's also like grayscale color modes you can use, which are the ones I usually use are just grayscale, because I'm colorblind.
You've been taught appropriately, Ben.
Yeah, I've been taught appropriately, and I'm also very colorblind, so I have to do it for my own reasons. But what we've got here is quite interesting. We've got some data here. We've visualized that. One thing I'll do before we move on to the next thing is I'll just show you if you wanted some kind of legend for this. So you wanted to say, this blue one is whatever, and this red one is whatever. I think you can do that using this, and if it goes wrong, then don't worry. I'm just trying to remember this off the top of my head. So label equals female. Put a label like that, and you can say label for this thing equals male, like this, right? So you're just adding another parameter and saying label equals female, label equals male, and you can do plt dot legend, I believe. And let's see if I'm right or if I'm completely wrong, if I'm misremembering this. No, yes. So as you can see, it's made a little thing saying this is female and this is male. So if you wanted to add that, you can do it that way.
Can you just one of my favorite things about Replit as well? Can you just put a comma after male, because I just want to show the parameters.
Yes.
So this is something that's really useful, right? I struggle to remember all the commands I can do. So for every one of these things like scatter and bar and basically any function in an extension, I haven't written the extension. I don't know all of it. I've probably not even looked at the manual. But if I put a comma in there, it will tell me all the things I can do. So again, it's you got the mark. You know, you can change the marker type, for example. And that's what I was talking about earlier. You can change the marker style. Alpha is the level of transparency. Line width in this case, it doesn't really make any difference. But that can be really, really useful. Sometimes you know what you want to do, you just can't remember the right command. Put a comma, just look at what it pops up. Really helpful.
And another related one to that is if you want to, for example, you can't remember off the top of your head something that Matplotlib does, you can do the same, but instead of a comma, you can do Plt Dot, and it should come up with. Oh, hang on. It should pop up with things you can do with that. So as you can see here, it's loading whatever it is, but it should pop up with all the things you can do in this. So you can do things like bar chart. We've already looked at this, right? We've got barbs. I'm not sure what that is, but I think it's some kind of plot. We've got box plots. You know, you've got all kinds of stuff here. You've got contour plots and all kinds. And there's also, you know, there's also pages for the, you know, the API reference for Matplotlib. So you can actually have a look at these on the Matplotlib website. But there's all kinds of stuff you can do in it. And I frequently use dot and comma like that just to scroll through and go, oh, actually, what can we pass to this function? What can we do? So I suppose the next thing to do is we've had a look at scatter plots. I'm just going to comment this out. Let's have a look at another interesting one, which is histograms. Now, histograms are really useful tools, right? And if you've ever tried to make a histogram by hand or anything, it's awful, right? But things like Matplotlib allow you to make histograms very quickly, So for example, if we do something like Plt Dot Hist, which stands for histogram, we can put in something like male height, and as you can see, look, there's loads of parameters here. You can specify the number of bins in the histogram and the range and so forth. But if we put in male heights in here, you'll see that we should get some kind of histogram here, and it won't have labels and stuff, and it won't have a title. But what Matplotlib will do is it will decide how many bins it needs for that histogram, and histograms are very useful. There's other things you can do. Hopefully when it shows this, it does take a while to initially load the GUI. But yeah, so what you do with histogram is you just pass in your data. So you pass in all your data, and it will spit out a histogram at the end of it. Let's see if this is running. I think it just stopped for some reason. It does this sometimes.
Show.
Yes. Again.
Needs right, press print, then. Needs press print.
See, look, I've been using Matplotlib for years now, and every time I still forget the show thing. So
it doesn't help when there's a lot of pressure when you're live on YouTube.
Yeah. So just remember to always show. I was just sat here going, oh, it's really slow. No, of course it's slow because I haven't showed it. So just remember that. I always keep forgetting. So if you find yourself forgetting, don't worry too much. So yeah, here we can see a histogram, and you can see that they're kind of centered around. That looks roughly about 5'9"-ish. And
again, if you wanted to look at that closer, you could change the ticks along the bottom to clarify that a bit more.
Yeah, and you can change the number of bins. So here we have a couple of bins. We've got 1, 2, 3, 4, 5. I don't know. I'm not going to count.
Worth explaining what a bin is?
Yeah, so here we have what we're doing is we're splitting this range, the range of this data along X, into separate bins. So as you can see, there's like separate bars, right? There's one here. We've got 1, 2, 3, 4. You can see that there's a number of bars here. Now, if I put in the number of bins, I don't know, something like 200, what will happen is there's going to be more of those bars.
So think of it like, and again, heights is a really good example, right? So I'm bang on 6 foot tall, but I'm getting older, so maybe I'm getting shorter. That's what the data's telling me. Now, if we were to ask everybody in a sample what their height is, actually, am I exactly 6 foot tall, or am I 6 foot 0.1? Right, 6.001 or something like that. I would just be described as 6 foot, and if I was describing my height, I would say 6 foot. Now that's a useful way to look at data, and we call it binning. We call it almost categorizing similar units of data together.
Yeah, and this histogram thing allows us to do that, so we can change the number of bins. The fewer bins we have, the wider that range is going to be. So it's almost like the way I kind of think of this is like grades. So you can think of the process of taking a percentage, like I don't know, 76%, and assigning that to some kind of category, like first.
Actually, that's an excellent example, actually, then, because for anybody who's been through GCSEs, where you can get A star, A minus, B star, B, C minus, D, E, F. There's a huge range of marks that you can potentially achieve, right? And the difference between, say, 63 and 67 can be the difference of a grade. Then you move to university, and suddenly we're on fail, third, 2-2, 2-1, first. Now I only have 5 bins. Before we had something like, I think there's 14 grades at GCSE, from A star down to U. Now we're down to 5. So we would just be changing our bins. So the same mark, again, depending on that range, will change. Now, this is a really interesting thing we sometimes talk about the honesty of data visualizations. Sometimes, if you want to tell a specific story, and you see this quite a lot in the press, they will change the bin size of their data to make it tell a different story. So again, in this, if we binned, say, all the people above 6 foot into a single bin, it might look like quite a tall bar on a histogram, right? So sometimes we can make the data as well. So we wouldn't do that. We're scientists, but people can sometimes make data look like it's telling a specific story by dishonestly managing their data visualizations.
Yeah, and I really quite like using histograms for analysis and stuff. It's quite hard to initially get your head around them, but they're really useful. One of the cool things you can do with these. So we did a scatter plot and another scatter plot in the same figure. You could do the same, but for something like you could do the female heights and the male heights and use 20 bins. So what you can see is a difference of where these two groups are. So as you can see, there's clearly 2 peaks here. So there's 2 very clear distinctions between these groups. And it's something that you could use in your paper or something. So yeah, there are other things that we can look at. So there are other types of plot in Matplotlib. One thing I'll just very quickly mention. So say we go back to our male heights like this. Matplotlib, sometimes if you want to highlight exactly where the mean is in this data, you can actually draw a vertical line on the graph. So say, for example, we have our mean, and it is just statistics.mean of male heights. So we're getting the mean of them heights, right? And we can do something like Plt dot axv line. This means axis vertical align, and you can pass in the mean into here. So what this will do is, well, I'll show you what it does. It will just put a line exactly where that mean is. And I use this sometimes. I mean, sometimes you don't. Well, it's the wrong color, but as you can see here,
you can change the color, right?
Yeah. So you can assume you've got something like color equals red or something. I'm just going to assume that works. And it's probably not the best idea to use red on top of that, but as you can see, look very clearly, this is the mean. We can put lines wherever we like. We could use horizontal lines even. We could make them. We could find the, I don't know, the mean of this frequency or whatever, and plot that as well. But you can use little tools like this, very useful for analyzing your data.
For example, a reason you might want to do a horizontal line on this is to show the mean age.
Yeah.
Because actually the intersection of the mean height and the mean age is an interesting point in this data.
Yeah. But yeah, there's all kinds of stuff you can do in Matplotlib. So we've covered some stuff. Last thing probably the last type of chart I'll show you is...
and you didn't think this episode would last an hour, Ben.
Yeah, I thought it wouldn't be that long. But I think the thing is that Matplotlib has so many really cool tools. Some of the stuff we're showing here, they're basic. It's just the basics. You can do all kinds of stuff in Matplotlib. There's you can even do 3D charts if you wanted to get into that. There's all.
Don't do it.
Don't do it.
Don't do it. There's no need to do 3D charts.
Yeah. Even things like box plots and stuff. There's all kinds of stuff you can do with this. Probably the last one I'll show you is one I use not all the time, but it's very useful sometimes when you want to look at the intersection between two series of data. So you can do Plt.Hist2D. What this is it's a 2D histogram, right? We can pass in something like the male ages and the male heights, and this will give us a histogram that is 2D, and it can be useful in some cases. So let's just have a look and see what this looks like. So if we run this, it should give us basically a histogram, but in 2 dimensions. And you don't use this often. It depends really what you're analyzing, but it can be very useful. I use this for things like heat maps and stuff. You can use it for things like heat maps, but hopefully, yeah, it shows. So you can see along the bottom we've got that's ages, and along the top we've got heights. So you can kind of look and see here that it's most frequent in the middle, and there's some interesting things you could draw from this, right? Especially, now you're looking at the frequency of ages and their heights, right? So you can see that people who are 20 are most frequently between 5'9" and 6 foot, but as when you're 50, for example, the most frequent it seems to be around 5'7". The data is more spread out, so you can do some very interesting stuff here with that kind of thing. Yeah,
you'll be surprised. To be honest, if there's a specific type of plot you want to do, it is probably available. Again, you can look at the Matplotlib library. It's all there. It's all available, and the best thing, it's all free.
Yeah, all free.
And the other thing I would say about Matplotlib and Python over other popular plotting, it runs on really underpowered computers as well. Looks like a Minecraft texture to me. Yes, something like that. You don't need a powerful computer to run Python. You'll be surprised. Again, I've had machines in the past, laptops that have struggled with some of the plots I've tried to do in Excel. And again, if you've ever tried to do a plot of a very big data set in Excel, it can sometimes struggle.
Yeah.
Python and Matplotlib, beautiful.
Yeah. The cool thing is as well is, as Chris kind of mentions as well, is that with Python we can churn through massive amounts of data. What we've been showing you is reading in a CSV file that has 1,000 records, I think it is. But we could be looking at data sets with millions of records, and Python gives you all the tools available to actually speed up that. Things like multi-threading, you could use this with your to compute your data and then plot it using Matplotlib. You don't even need a screen to work with Matplotlib. You don't have to use this show thing. You can just save it out to a file like I don't know, let's call it hist2d.png. You don't have to show this. You can just create the file and don't print it. So you can do all kinds of stuff with this. It's definitely worth looking into it. So here we haven't showed it, but we've still made the file. And sometimes you just have scripts which just make, tons of these charts and just spit them out into a folder.
So I've done this for papers in the past, where I've literally been processing loads and loads of data, and I've just had a Python script that I've run it through, and it just chucks out a bunch of charts. Because I know I'm always essentially doing the same kind of graphs. All my data is labeled the same way. I only ever need to write it once, and it just works.
Yeah, it's Matplotlib is a really, really good library for that kind of stuff, where you want to do some good processing, like some processing on your data, and then plot it. And you want to plot loads of these charts and save, hundreds of these charts at the same time. It's very useful for that. So, for example, my PhD, the data I'm analyzing in that, there's millions and millions of records, and there's thousands of files. So I have to process each file and spit out a graph for each one of those files. There's no way I could do that in Excel. There's no way I could do that in something like Octave or MATLAB. So I use Python. I use Matplotlib for that. It's a really, really cool tool. And as Chris talked about, there's tons and tons of different plot types out there. And if there's one that you really want to use, somebody probably out there has made that particular type of graph. So things like stream graphs, or more esoteric ones like, I don't know, I think they're called violin graphs, or whatever they're called, violin plots. You can find implementations for those kind of charts in Matplotlib.
And sometimes it's not even, I mean, this is the joy of Python. You can extend things like Matplotlib, and you'll find people who've written their own libraries that build on Matplotlib to do all kinds of weird and wonderful and wacky data visualizations.
Yeah, you can. There's absolutely tons of stuff out there, and I think the best way to have a look at the full range of these is to have a look at the API reference. There's tons of stuff out there, but as Chris says, that people build on top of this. There's other visualization libraries that use Matplotlib, so it's definitely worth checking that stuff out. So yeah, let's run this again, and I think that's all the charts I wanted to look at. I think maybe I should show the API reference for Matplotlib. So if you want to go about and see what the library has to offer, there is this. So this is Matplotlib's API reference. We've got all kinds of stuff in here. So you've got, and if you want to go here, it is matplotlib.org/API, and everything's in there. So it's just matplotlib.org, and yeah, it's all on there. So you can see, I'll zoom in a bit. There's all kinds of stuff here. There's, you can turn on the box. You can do.
There's the thing we were talking earlier about the scaling, that you can turn off auto scale.
Yeah, and I think probably the best way, you can even do pie charts if you wanted to, and polar
Don't do
charts.
pie chart. All right, no. Pie charts are the worst type of data visualization ever created. They are so bad for so many highly published reasons, and people still keep using them. It drives me nuts. Don't use pie charts. They're bad.
The other bit of advice that I'd probably give as well.
He's doing it just to wind me up at this point.
That's exactly why I mentioned the pie chart. But there's if you want to, I think probably the best advice I can give is if you're looking to do data visualization with Python and Matplotlib, and you want to do a particular type of chart, but you don't know where to start, go onto Matplotlib's website and click the examples here. So it has this little gallery of charts that people have made. So things like a stacked bar chart. If you wanted to look at the code to do this, then it's here. Here's the code to do it. You can do it with this. So there's some really, really good stuff on there. They've got all kinds of stuff. Hatch-filled histograms.
Bar charts with gradients. Oh
God, that looks awful.
Why? Why would you do that? That looks like a vector artist has tried to do some sort of logo of the New York skyline or something at sunset. It's horrible. Why would you want that chart junk? That adds nothing to your data. Don't do it. Oh,
it looks terrible.
Oh, I'm getting a headache.
looks very, very
What? Look at
vaporwave.
all that code to make
Yeah.
that colossal menace. Please. So go back. Let's have a look at some proper charts.
Yeah. So let's have a look. We've got.
Right, okay. Yeah, nice.
Scatter plot with histograms.
Yeah, that's not nice chart. So stream graphs, like a good stream graph.
Yeah, exactly. There's all kinds of stuff here. There's other things, barcode for some reason. If you wanted to use that,
that's going to be useful.
Yeah.
Constantly finding myself in the need to print out some barcodes from data.
Yeah, there's just is that a picture of Grace Hopper?
Grace Hopper. Don't know who Grace Hopper is. Google her. She's fantastic. Documented the world's first computer bug. That was literally a bug that had flown into a computer and fried it. Grace Hopper is an absolute legend of computer science. Strongly recommend looking her up.
And there's all kinds of stuff here. There's watermark images if you wanted to watermark your plots for whatever reason. There's all kinds of stuff here. Let's
find lots of wonderful ways to make our paper unsuitable for publication.
Yeah, but as you can see, look, there's even 3D surface plots and stuff here. There's all kinds of esoteric plots are on this page. So just if you want to look for a particular chart that you want to use in Matplotlib, have a look on this page. It'll probably be on there. Most common chart types are on there. So yeah.
And on that note, we've come to the end of our 8-episode series. It's been absolutely great fun. I hope you found these episodes really useful. We do have plans for a season 2 of the Ben and Chris Show, although it's going to be a little bit down the line. But we are looking for another YouTube show on programming, which we'll be announcing in the near future. But by all means, if you've got any feedback, please let us know. Drop us an email. Chris Headley and Ben Williams. You can find our emails on the University of Lincoln website. Drop us an email. Let us know what you think. And please do check out the webpage. All the episodes are there. We're a little bit behind on some of the worksheets, but they'll be up soon along with the data set that we've been doing this. So you can, by all means, you can plot some of the height charts that Ben's been doing today. But it's been absolutely fantastic. And Ben, have you got anything you want to say? The last episode was quite emotional.
Yeah, I really hope you enjoyed it and you got something out of this series. I think all the stuff that we've talked about, I'm really really passionate about this kind of stuff. So if you have any feedback, about how we can if you have any feedback about how we can improve it or how it went, I'm more than happy to have a look at that. But yeah, I've really enjoyed it actually. This is something I've always wanted to do, is sit down and talk about this stuff. I'm glad I had the opportunity to. So I hope you guys enjoyed it.
Brilliant. So until next time, I've been Chris, he's been Ben, and see you soon.